This example is a classic integration by parts example. It's one where you have to use integration by parts 2 times, and then you get back the original integral and you have to solve for it. You just have to learn to recognize that the technique that you can use to evaluate this integral is integration by parts. So we're going to set this equal to u dv, and we're going to start by choosing u. With many integration by parts examples, you always choose u to be the function that you can differentiate to eventually become 0, or that you can differentiate and it becomes more simple. Neither of those work here. So for this example, we can choose u to be either e to the x or cosine x. It doesn't matter which one. I'm going to choose u to be e to the x, and then we'll erase that other highlight, and our dv is what's left over, cosine x dx. On the left-hand side, we'll take the derivative. So we have e to the x dx. And on the right-hand side, we're going to integrate, and the integral of cosine is sine of x. Now we can apply the formula that I've written over here on the right-hand side, and we have the integral e to the x cosine x dx. It's really helpful to write that down for this type of problem. We're going to multiply u times v, and that gives us e to the x sine x. And then we're going to subtract off v du integrated. So we're going to subtract off the integral of e to the x sine x dx. Now I want you to notice that we have an integral that looks very similar to the one that we started with. What we have to do is use integration by parts again, and here's the super important part. You need to make sure to choose u to be the same function that you chose originally, either the exponential or the trig. We chose it to be the exponential, so we're going to again let u be e to the x, and then dv is sine x dx. For the u, we will take the derivative. We have du is e to the x dx. And on the right, we have v is the integral of sine, and remember that's a minus cosine. Now let's see what we get. We can't forget this first term here, e to the x sine x, so we'll write that down. And then we're going to subtract off u times v. That gives us minus e to the x cosine x. And then we have a minus the integral of v du. So that's minus the integral minus e to the x cosine x dx. We'll wait till the very end to add our plus c. Now let's work with these negatives. We'll multiply that through. We have e to the x sine x plus e to the x cosine x. These two negatives become a positive, and then we have another negative hanging out in front. So this becomes minus the integral e to the x cosine x dx. That's a really common mistake right there, is to not keep track of those negatives properly. Now what I'm going to do is I'm going to come over here to the left, and I'm going to rewrite what our integral was. E to the x cosine x dx. Notice that our original integral turned up again when we integrated it. So all we have to do now, let's give us some more space here, is we're going to bring this integral over here to the right. So this gives us 2 times the integral e to the x cosine x dx. And this is equal to e to the x sine x plus e to the x cosine x. Now all we have to do is divide by 2, and we'll pull out our e to the x because that's a common term, and we'll add our plus c. We have the integral then, e to the x cosine x dx is equal to 1/2 We'll pull out the e to the x. We have sine x plus cosine x, and then our arbitrary constant plus c. And there's our final answer. I would put a star by this problem and just remember, we'll go back here to the top, that this problem is one where you have to use integration by parts 2 times and you get back the original integral. If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.